Hello, welcome to Nostalgic Math Chats. We are looking at question 8b, yes, from IEB May 2023, paper 2. Let's get into it. In the diagram, O is the center of the circle. We love it. Chord AB is 8 units long. Okay, so I'm just going to highlight that for myself. So that is 8 units. Okay. The perpendicular distance from the furthest point C on the circle to chord AB is 8 units. Okay. Right. Okay. Determine the radius of the circle with center O. Okay, so the first thing here is just thinking about this piece of information here, right? The perpendicular distance from the furthest point C on the circle to chord AB is 8 units. So instinctively, I feel like that if I were to draw that perpendicular line from C to AB, it would necessarily go through the center of the circle. But I need to think about why that is. So how am I so sure that it's not something like that doesn't go through the center at all? So is it possible that that is also a perpendicular line? And I think instinctively, we can see that this is false. It can't be perpendicular. And I think it's because in order for it to be the furthest point away, it would have to lie on the diameter. Yeah, because I'm just trying to think. Suppose there's a point here, and we try to find the perpendicular distance between it. You can see that that's short. I don't know how to put this logic into words. I need to sleep on it. And I might be overlooking something very simple, in which case please forgive me. But how do we put this reasoning into words to say that the furthest point C, if I am to join it to the chord AB, it must necessarily go through the center. So I can kind of see that if I choose any point closer than C, then the perpendicular line won't go through the center. It will only go through the center if it's going through C, if it's from C, which is the furthest point away. And then I can also kind of intuitively see that if it doesn't go through the center, then it wouldn't be perpendicular. Anyway, so that's an interesting thought. So let's just kind of then stick with the intuition for now, in the absence of being able to reason about this properly. But yeah, I will have to make a follow-up video to kind of explain why this line does indeed go through the center of the circle. Yeah, because if we knew that it bisects this chord, then we would know that, okay, it does go through the center of the circle, because we know that first theorem, is a different, it's a combination of it goes through the center, it's perpendicular, it bisects the chord. So if two of those conditions hold, then the third one is also necessarily true, but we haven't been told anything about it bisecting the chord, so we can't use that. Anyway, so righty-doos. We are asked to determine the radius of the circle with center O. So essentially we're asked to find what is the length of CO, for example. And there are many other radii, right? Like those would all be radii as well. We'll see if we need to construct those. But for now, let's just call this guy X. Okay, and we are told that this whole thing here is 8 units long. And so this distance over here is 8 minus X. Okay, and then we need to figure out the radius of the circle. And I mean, this kind of question, I think actually the question before it was to prove the theorem that if you have a perpendicular line to a chord passing through the center, then it will bisect that chord. So it already you're kind of primed in terms of which theorem to use to solve the problem. But yes, we know that that's a 90 because that's given. So we then do indeed construct our little radius over there. You know what? Why not use a ruler when a ruler is available? Why not? Why not? Okay. So, yeah, you don't use it because it's hard. That's why not. It's hard to use. It's too hard. Right. Okay, so we know that OB is also then going to be X units long. Ooh, interesting. Yeah, this is a bit of a flop actually, because now I don't know what this is. Oh, I thought I knew where I was going, but I do not, I do not, I do not. So, kind of back to the drawing board, hey. Okay, so I'm trying to think what else can we utilize. Maybe there's some simultaneous equations. That would be rough. But yeah, we know that if that's y, then this is also y, right? Because of the theorem that tells us that chord gets bisected. I'm also thinking about possibly extending this, right? Who knows? So that length over there would be x minus 8 minus x, which would be x minus 8 plus x, which is 2x minus 8. Who knows if we might need that. Oh, chord AB is 8. Oh my goodness, I'm being so thick. Oh, Jehovah. Welele, my goodness. Oh, wow. The horror, the horror. Okay, so I highlighted the chord and then still proceeded to ignore the information. So we're told that chord AB is 8 units. So we know that this and this will each be 4 and 4 because of the theorem that I mentioned. Oh my goodness, okay, I feel so embarrassed. Right, so then we can use some Pythag. It got dark so quickly. Okay, so this is 8 and this is also 8. Okay, anyway, that might help reason about, anyway, let's not stress too much about it. So let's just solve our Pythag. So let's say construct diameter passing through C and O, well, obviously passing through O, which intersects with AB at, let's say, M. Okay, so I'm just going to rub a whole lot of this stuff out so that it is clear what we are talking about. Wow, did it just decide not to erase my stuff? Okay, anyway, so we are constructing, oh, this is actually nice. Let's use that. Right, so we're constructing this diameter and it passes through C and O, and we're saying that it meets the chord AB at M. Okay, and this is just so that it's easy for us to name stuff. Right, and then we say let the radius of, oops, an alarm is going off, my bad. Let the radius of the circle be x units, right? Then OM, right, as we showed, is going to be 8 minus x, right? Because we said that this bit over here is x, and so this remaining part must be the difference between 8 and x. And then we know that OB is equal to x because it's a radius, right? And then, okay, we've been told that this is perpendicular. So then we know that MB is equal to half of AB, which is equal to 4. And that's because perpendicular line through center, right, bisects the chord. Right, So we are all set up for some Pythag. So we've got 8 minus x over there, we've got x over there, and we've got 4 over there. So then Pythag tells us that, okay, maybe let's not do that. So Pythag tells us that 8 minus x squared plus 4 squared will be equal to x squared. Right. So then we expand that. So we've got 64 minus 16x plus x squared plus 16 is equal to x squared. Right. Those x's are going to cancel each other out. So then we're just left with x squared plus 80. No, there's no x squared. Oh my goodness. I was about to be so confused. Okay, so we're just left with negative 16x plus 80 is equal to 0. And if we then say 80 is equal to 16x, that will tell us that x is equal to 5. And so the radius of the circle is 5 units. Wow, that was harrowing. Let's check if we got the answer right. So this is question 8b, and we do indeed have r is equal to 5.